Moderator, I can't hear you. You're muted. Sala.
Sorry, you can.
It looks like I can record.
Yeah, I just got a notification saying it's recording, and asked if I want to stay
or leave.
And I'm not sure if it's recording to my computer or recording to the cloud, but it actually doesn't make a whole lot of difference. Recording to the cloud is a little bit better because you get captioning.
I think it's recording to the cloud.
Yeah.
Because it's got the cloud record icon.
Okay. Okay, good. So we've got
Geoff, are you in your like the browser version of this?
No, I'm in the Windows client.
So that's it. I think Ed and I must be in the browser version. It seems rather limited.
Oh, okay.
Right,
Yes.
right. I
browser
could
client
rejoin.
is...
Well, I'll tell you what. I better start it because it's 9 o'clock now here, and then I can try to rejoin while the talk continues. I can try to rejoin with the direct Zoom link, and then probably I can use a virtual background. Okay, so I'm going to pause. Okay, well, my name is Ed Geringer, and welcome to the workshop on computer architecture education. I'd like to welcome you to, I think, the 20th or 21st, and I can show you a list of the others. So here we have the session. We have the URL. I think also go.ncsu.edu/WCAE will get you here, and you can just, but Google will know this. So if you can see a list of all the workshops on computer architecture education that we've had since 1995. And the first few, well, we couldn't find the website, but starting about 1996, we've got the websites. A few of them have moved. And then the papers, if you want to find some of the earlier papers, you can go to the archive here. And maybe I can increase the size of the font. And we have the papers from the early workshops. So if you want to see the very first paper presented at WCAE, you see that one from Dan Sawarek in 1995. Dan's still around, still doing ECE. And then we have papers from then on until 2006. But starting with 2007, they were in the ACM Digital Library, so we just have the slides up on the site here. And then you can go back and see a complete list of workshops. Now this paper, today's workshop, is going to be an IEEE Explorer. It turns out that ISCA has been alternating for many years between IEEE and ACM for publications. And we've managed to hit the ACM years because ISCA has been, or the WCAE has been in the odd-numbered years for the last decade, and that's so we can hit the FCRC, by the way. And so we've hit all of the ACM years, but because of the pandemic, somehow related to the pandemic, ISCA didn't change publishers this year, so it's with IEEE. So there'll be an IEEE Explorer as soon as we can get them uploaded, and I'm collecting them now. And if you're a presenter and you haven't uploaded your latest version of the paper, please upload the final version, and then I will assemble them and submit them after the workshop. In the interim, your papers are going to be available from the workshop site, but once they're in Explorer, once you've signed the copyright agreement, we'll take them down and serve them in that way. Now, the schedule today is we have several sessions, and the sessions begin approximately at the top of the hour. We have the keynote session here, and then the next session is pedagogy and online adaptation, followed by mentoring, and then tools, and then architectures and embedded. And the last one is a vendor session. I should mention that we've added a presentation from Redwood EDA at the very end of the workshop, or depending upon when the workshop starts, when the session starts. If it starts a little bit early, we might hear from them first. But in any case, they'll be added. I had arranged to put that session on the schedule, and then I forgot, and the presenter contacted me yesterday, and whoops. And so it's very convenient that the vendor session was at the end, so we can hear from that group. And I've got a little typo here to correct. Okay, so with no further ado, let me turn it over to Geoff Herman, who was the outcome of our quest for a keynote speaker. We thought, well, who has been distinguished in pedagogy and doing computer architecture for teaching? And Geoff's name came to mind, and so Geoff is the presenter. So let me turn the floor over to Geoff from the University of Illinois. Geoff, take it away. You're muted.
There's my mute button. Yes. What would a Zoom session be without someone starting off talking muted, right? Good morning or good evening, wherever you are in the world. Welcome. Thank you for having me. It's a real pleasure to be here. As I said, my name is Geoff Herman. I'm a Severance Teaching Associate Professor in Computer Science at the University of Illinois. And this is a lot of what this talk is around is a lot of work that I've been doing with several of my colleagues, trying to think, how do we assess student learning better so that it can improve learning? And I'm going to use a lot of examples from my own computer architecture class as I talk about this. But as I mentioned, I do want to start talking about several of my colleagues. Like none of this work is like solely done by me. Like this has been massively collaborative types of efforts across all of computer and engineering education research people at Illinois. And so they've a lot of people to thank. I'm just going to show all their pictures. And I want to thank them for the ways they've helped and supported all of this. And I also want to give you a little bit of context about kind of where this is situated within the University of Illinois. And again, this is kind of a thank you slide to our Academy for Excellence in Engineering Education, which has been instrumental in just providing a lot of faculty development and support and resources for us to do a lot of this work. Particularly there's two programs, the Strategic Instructional Innovations Program and the Education Innovation Fellows. And these two programs have provided a lot of the framework for us to be able to create things like our computer-based testing facility, create a lot of the online tools that I'll be talking about a little bit, as well as the ability to organize faculty to do some of these research studies that we did at large scales. And so just wanted to do a quick shout out and thank you to quote my sponsors, as well as the National Science Foundation, who's also provided some support for this work. Okay, so to kind of situate my work, we've done a lot of education research that's focused primarily on rethinking what we do in the classroom. What do we do with our pedagogy? And there's been generally a sense of active learning is very important for improving learning. And so there's been a lot of emphasis on moving from chalk and talk, where we stand at a chalkboard or a PowerPoint slide and talk to you like I'm doing right now, as the primary mode of communication with students, to trying to say, we want to engage students in interactive engagement activities where the students are actively creating and constructing their knowledge. And so we see this with things like peer instruction or clickers, where students are being asked multiple choice questions in the classroom. We see this with collaborative learning, and where we give students complex, interesting design tasks or analysis tasks, and we ask them to work with those with their peers and teach their peers as they are engaging with that. And so there's a lot of evidence. I can point you to several meta-analyses and studies that say yes, active learning is way better than kind of just talking at students and just having them listen. The problem is that's just a small part of the learning process. And I think one of the problems or challenges that we leave is that if all we focus on is the pedagogy that we do inside the classroom, we're actually ignoring huge parts of the learning process and missing many opportunities to maximize students' learning and engagement beyond this. And this is why we've really started to focus on and think about assessment as part of that puzzle, and how do we maximize the use of the assessments that we have students do. And so this is just a brief summary of a lot of cognitive science. is that learning is enhanced by frequent low stakes testing. And if we think about like the stereotypical model for lots of classes, particularly in STEM, is that we often have like this 2 midterms and a final model, where like each midterm is like 20% of the grade, the finals are 30% of the grade, like these big tests. And what a lot of the research has been showing is that basically students engage in what we can call, like, for lack of a better word, like binge and purge learning, where they study and cram and work really hard to try to study for this exam, these high stakes exams. They study and then they immediately forget what they just studied. And like if you ever teach like a sophomore, junior, senior level class, it's really obvious. Like sometimes like, you guys have seen this before, right? That experience of like, I know they taught you this in the previous class, but the students are like, I've never seen this before. And that kind of phenomenon is indicative of the type of learning we see with really high stakes testing. But one of the things that we know and have learned is that if you engage people in small, frequent assessments, it actually is a great way to train your brain. And one way to think about this is by way of analogy. I don't even know if it's so much of an analogy, it's just a way of thinking about it, is we are biological systems, right? Like, if you want to get in shape, you have to exercise on a regular basis. You can't just, like do 30 hours of exercise and expect, well, okay, I'm good for the month now. You have to do small investments in exercise because that is how your body transforms. Your body needs to work and then recover, work, recover, and rest. And the continual coming back to the activity is what changes your biology. And in much the same way, our brain is a biological system. In order to help it to be able to change, it needs to have lots of small investments. It's just not designed for binging. And it can make small incremental changes over time. And so we need lots of small tests to be able to create change in the ways our minds work and the ways our brains work so that we can learn. And so that's a really core principle. But one of the challenges, which I think is key here, is what types of practice, what types of testing actually lead to this type of learning? Because one of the challenges that we will see, and I think we see this in our classrooms, is that even like on something like homework, which is supposed to be a practice and a small testing environment for students to practice this, students often are relying heavily on, help from a TA, help from a friend, guess and check, whatever it might be. They aren't actually necessarily thinking like, okay, I have to get this question right. And I have to do this. It's, I'm going to try until I get stuck. And then I'm going to give up. And then I'm going to ask a friend, or I'm going to turn to Chegg or GitHub or whatever it might be, or Google, right? And in many respects, the students are not producing the knowledge. They're curating knowledge for their homework and stuff like that. And so, and just even several research studies have shown that basically for most students, rereading the textbook or rereading the lecture notes or rewatching video lectures is their primary mode of study. They don't think to do, oh, I should do more practice problems. I should take a practice test. I should really quiz myself as if I was in an exam environment. And they just don't do that. And so there's a lot of research studies like this one. I picked one out of like hundreds that I could show here that basically show that when students engage in kind of this, I'm going to reread or rewatch a video lecture, that there's some immediate gains. Students do learn something at that time, but as time goes on, the amount of learning that they retain decreases. Whereas if students engage in a short practice test, where they actually tested themselves and and there are some degrees of stakes to that learning, they remembered more. And so like this is a really small study. Students studied for 7 minutes and then, took a short practice test, that's only going to be a couple minutes long. And that little bit of difference, students, spent less than 10 minutes, we can start seeing differences in student performance at very, very small doses of treatment, so to speak. And this is really exciting. It's like something which there's been a lot of studies of this in very controlled lab environments. And some of the big questions of how do we translate this type of research into the classroom? And that's been a big part of my research program up until now. Okay. So I realized I meant to say something. If you have questions or whatever, feel free to put something in the chat or unmute. I'm happy to have dialogue through this. I don't have to just talk at you for 40 minutes. I'm happy to take breaks and interact. So so basically, what I would argue is that from the cognitive science, what we can argue is that we want frequent or small testing environments where, and potentially even multiple chances for students to go back and revisit and relearn stuff that they didn't learn. And so really wanting to challenge this mindset of like, let's have, okay, yes, I'll get you a copy of the slides. 2 midterms and a final. Rather, like, can we have multiple, like lots of small assessments, several midterms over a semester, and maybe can we also explore the use of second chance testing to get students to really come back and relearn? And one of the big things that I didn't talk about in the cognitive science is what we call the testing effect, is that you're often most primed to learn material right after a test. And so after you take a test and you get some feedback that was high stakes enough, your brain's like ready, like that was important. And if you go back and revisit, you're most likely to learn at that time. That's another piece of the puzzle. And so how do we get students to engage with this? From a more like cultural sociological perspective, one of the big challenges, particularly it's for all students, but I think it potentially disproportionately affects underrepresented populations or underprepared students, is that their expectations of what a college level class is going to be like is very different from reality. For many students, they just came through high school. High school was easy for them. They didn't have to study. They didn't develop study skills because they were the best at their class. They got their 4.0 with very little effort. They just, came to class, took the exams, did great. And that no longer works inside at the college level. Our exams are much harder. The classes are more challenging. And so there's this huge mismatch. And one of the big challenges for students then is, how do they adjust? What do they have enough time to engage their metacognition to realize, oh, what I thought the tests and exams are going to be like in a class are very different. The types of things that I'm expected to do with my knowledge are much more challenging. And this is just like a meme I grabbed from, from Reddit or whatever, that's expressed like, this is students realizing like, oh my gosh, classes are so much harder than I expected. And that's a big challenge. So there's a couple of different ways that people have tried to explore using assessment to improve learning. And so again, like our default is this 2 midterms and a final. And one of the things that concerns me is if you have a student with low ability, they might fail that first exam, or just, they do okay. They get like a B or a C. They didn't master the material. But the problem is with a lot of our engineering classes, particularly in computer engineering, I know my class, it's all cumulative. If you don't know how to do Boolean expressions, you can't build the bigger circuits. If you can't build the bigger circuits, you can't reason about an architecture. If you can't reason about architecture, you can't do anything else. And so that students who are struggling a little bit at the beginning fail as they go towards the end. And so I saw like one of the talks later today is going to be about mastery-based learning. And there is one of the appeals of mastery-based learning is that we use assessment as a way to help students metacognate and realize, oh, I actually don't know the material as well. I need to go back until I master it. And that leaves them better prepared to engage with later material and increases the possibility that everybody will master it. And I think having done some mastery-based learning, one of the challenges is some students just take longer than we have in a semester to get to mastery. And what do we do about that? How do we help students? It doesn't always fit nice and neatly inside the course context, and that students are going to work at dramatically different paces. How do I manage, 400 students all working at their own pace? How do I provide support for them? And that poses a very difficult challenge. And so one of the motivations that we've explored second chance testing is that it kind of allows us to keep students in sync, but hopefully for that student with borderline mastery, they might go back and revisit some material and develop slightly better mastery of earlier content so they don't fall completely behind. They have a reason and a motivation to go back, shore up weaknesses in their understandings so they're better prepared for future learning. Okay, so a bit of context about what we've been doing at the University of Illinois is we have two platforms that I just want to talk about to help you understand the research studies we've been doing. Is we have a computer-based testing facility and a online learning platform called Prairie Learn, which is kind of custom designed to try to promote assessment-driven learning. And these are all like my collaborators who we all work together to build these systems, and we're studying them. I'm primarily focused on the research side of this arm of this work, but I just wanted to, again, say thank you to all my colleagues for all their hard work, with which I wouldn't be able to do any of this. So Prairie Learn is it's an online learning system, nothing that's not special in that sense, but one of the big things that we've tried to do is, support any type of engineering learning that we might want students to do. So it's like, hey, we have support for autograders for programming, like in Verilog or assembly or whatever it might be. Support for symbolic notation. So if you give students a circuit, they can convert it into a Boolean expression, or convert a Boolean expression into a circuit diagram, or stuff like this, where it's like I give students a data path and I ask them to annotate the data path. And so it's like, okay, hey, here is the add I instruction. Tell me what's going to be going on the data path for this instruction. And the philosophy behind this system, though, that's a little bit different, is that what we don't write questions, we write question generators. And so the ability of the system is basically you write code that'll produce as many variants as a student might want so that they can keep practicing. They get basically unlimited practice problems. And so this question isn't just one question, it's actually this instruction here, this add I instruction can be changed to an or instruction or a jump or a branch or whatever it might be. Any type of assembly instruction that they might use will be changed, and then all the answers will change in accordance. And this is one question generator that produces potentially infinite variants. And so students can do as much practice as they want. And this is very helpful for the creation of second chance tests or even mastery-based learning, so that you only have to write one question generator, but you can create infinite exams out of that. And then the other part of the puzzle that we've been trying to figure out is how do we make testing and assessments sustainable and scalable? And so we created this computer-based testing facility to basically provide security for making sure that students are actually being proctored, and that we have students, in a well-controlled testing environment to take exams. But rather than, trying to schedule a room for 400 students to take an evening exam, students self-schedule to take tests in this. And because we have this ability to create exams on demand, we can allow students to schedule at times that are convenient for them and work through all this. So this is, if you have questions about how this all works, I'm happy to talk about it. But some of the key points is we can rapidly produce new exams, and we can give these exams in a proctored environment with little overhead for the instructor, actually almost no overhead for the instructor other than choosing to. So I'll just write a question generator. Depends on the question. So I've written questions that are like, I write code to generate code, and those take a lot longer. But things like, something as simple as so this generating a circuit diagram creator is a little bit harder. But something like this, where I create this diagram once, and then all I'm doing is programming in here's how to decode assembly instructions, is pretty simple. I just need to do that once. And once I have basically my assembly to binary decoder, it gets pretty simple and quick after that. So basically I have a simulated architecture that I can just keep reusing over and over again. Yeah, that's a great question. It's one of these things where it's high upfront cost, but low maintenance cost, which is what I like. I can basically run my class pretty easily. Okay, so one of the big things that we've been doing with this platform is looking at frequent assessments, as I mentioned, and second chance testing. And I want to give you some perspectives of kind of some of the promising outcomes we've had from rethinking testing strategies. And again, this goal of low effort from me as the instructor, but potentially powerful impact on the student learning. So unfortunately, I wasn't able to do a really controlled study of changing this in my computer architecture class. We did do this in an introductory solid mechanics class in mechanical engineering, where basically all we did is we took the 2 midterms of the class and then, studied and examined what effect did this have on long-term learning. So how do students perform on a cumulative final exam that we carefully, it was a paper-based final. So we collected all the finals, and the questions didn't get released, and did as much exam security as we could for the study. And so what we did is change it from 2 like big high stakes midterms to exactly the same midterms in terms of the general structure, except we did some of these question generator stuff, randomized the numbers that students were given, and we just broke up those 2 midterms into 5 smaller quizzes. So same number of questions, same number of everything. So everything is the same except the spacing of the exams is the primary goal here. And what we saw on the final exam was basically that the number of students who failed the exam basically got cut in more than half. And the students who got A's on that final exam more than doubled. And so you see this massive shift in the distribution of grades in this one course, and with a moderately large effect size. And this is for almost like, this is basically free money, right? All that really changed was the cost of scheduling students into the exams, but with the CBTF, that's basically free. And so without changing the pedagogy, without doing major changes of the course, just spacing and scheduling the students' learning a little bit better, we are able to actually improve students' learning, which is what we'd hope to see. And we have seen similar replications, like similar effects in other classes that we've studied as well. So this is just one study that I can point you to. It's in applied cognitive psychology that we're seeing. So this is exciting and encouraging. Like there is some degree of translation from the cognitive science to the classroom about how we can improve learning. And we also wanted to make sure, like, as I mentioned, we're concerned about, does this affect different underprepared or underrepresented populations differently? Well, the encouraging thing is at least it's helping everybody. It didn't quite close all of the gaps between the different populations, but we did see every population was improving and benefiting from this type of change. So male versus female students or underrepresented minorities versus non-underrepresented minorities, we see that all students are improving in response to this change, which is good. That's what we're hoping to see, although we would have liked to see the gaps close a little bit more. And so just to give you an example of the way this looked for me with COVID this past year, I went to an 11 quiz model. So we used to have 3 midterms and a final in the course, and now we moved to this 11 small quizzes. And so one of the structures that we aimed for is like, okay, we're going to have each quiz is covering exactly one topic and really try to help the students focus on one thing at a time. So I was like, okay, Boolean functions, what are those? How do you convert between all the different, from Boolean algebra to truth tables to whatnot? Like, make sure you can do all of that. And then let's do this in Verilog, specifically with modular design, like things like full adders and multiplexers, how to use those within a circuit and so on and so forth. And so one of the important things about this was that we have a mixture of coding questions. So like things like, I want the students to write Verilog, they're going to get some automatic feedback and automatic grading of that. So we have like some MIPS assembly programming. We have students writing cache conscious code in C. We have lots of different coding exams. And then other questions like this Boolean function stuff is going to be pretty small. Okay, yes, great questions. Focusing each assessment on a single skill is at odds with the spaced repetition principle. Absolutely. So we do actually, so for specific exams, so like some of these, like number 4, number 7, number 11, we have like some review questions in there going back to earlier content, making sure that they don't forget about it. So like, we don't want you to forget about finite state machines. So we come back to finite state machines when we get to caches, talk about like, how do you model like a least recently used replacement policy with a finite state machine? And so we do some spaced repetition, but the goal is still like, hey, this is a unit. I want to make sure that you've mastered that unit before we move on and give students feedback. So just some quick reflections on my own, like the temptations and struggles that I've dealt with as I try to, move from 3 midterms and a final to this 11 quiz model is, we had 3 2-hour exams. That's about 6 hours worth of time, students butts in seats taking quizzes. And the real temptation is when you break it up into quizzes more, it's like, ooh, I have a small quiz. It looks really small. I can add more questions to it. And be really mindful. Like that's defeating the point of the whole purpose of this, which is trying to help students to have lots of small bite-sized engagements. We don't necessarily want to do more. We don't want them to work harder. We want them to work smarter, so to speak. And so really trying to be very conscientious to make sure that my quizzes were about, it's 11 quizzes, so they're about 30 minutes a piece. Some of them are a little bit longer. Some of the coding problems were a little bit longer. So in total, again, still about 6 hours worth of time is what I was aiming for. I'll answer the CBTF question. We weren't able to use the computer-based testing facility during the pandemic but we did have like online proctoring and whatnot, because our campus wasn't even open for the past year. So, so one of the other challenges, as I mentioned, is we have these coding problems. And for a coding problem, I want to make sure that I'm leaving enough time for students to be able to debug their code, because they are submitting this, and it can be really frustrating and very disheartening for a student to not have enough time to debug their code. And so there's that part of the problem. But if I just give students only one coding problem so they have plenty of time to debug, what happens if they can't finish debugging and they get a 0? Because if there's just one problem, it becomes a pretty high stakes problem. And so like when the first iteration of doing these 11 quizzes, I had like coding exams where there's like one big coding question, and short answer exams where it's just short answers. And the pretty consistent feedback I got from students was, oh my gosh, these coding exams are so stressful, because if I can't get this one piece of code working, I'm totally screwed. Never mind that we hand graded it and almost nobody ended up getting a 0, but that sense of, I leave the quiz, it's been auto-graded with a 0, nevertheless is very distressing for students. And so making sure that there's, even with these smaller quizzes, there's still enough variety of questions and number of questions that students can get some right, and that it doesn't feel like a complete disaster when they leave the quiz. And again, like I was saying, my goal is to help students to see, like, what did you just learn? Let's help you synthesize this last week or last 2 weeks of the semester and help you before we move on. Okay, so that's like kind of some of the stuff about frequent testing, and just like that, there is a lot of promise there in terms of that you can help improve student learning without actually doing more. Just how we dose our students and when we dose our students, so to speak. Okay, so the next part of our research efforts has been trying to study what's the effect of second chance testing, and does this actually help students improve their learning. And so we've had several research questions we've been exploring, like what impact does it have on student learning and exam scores? And particularly one thing that came up as we started having several faculty from our SIP program engaging with this is that lots of different faculty chose lots of different policies for how to administer their second chance tests. And so this became a question of like, what is a good policy here? And how do we help how does our policy maximize student learning? And another big concern, and this is a reasonable concern, is does second chance testing just become instructor sanctioned procrastination? Because if the first chance exam is low enough stakes, students just don't show up. And we've had a few instructors experience this where it's like, well, because there's a second chance, students like, well, I don't need to take the first chance. That's not the goal. Like, we want you to get some feedback and learn and grow. And so how does introducing a second chance affect students' preparation? And so the design criteria that we were looking for with this research is we want to maximize student mastery by the first chance exam. We want students to try that first exam and do their best. We don't want students to take unnecessary exams. That's extra work for the students. That's extra work for the course staff. That's extra grading. That's like extra logistics, because it costs. We did some math. It's like, it's $2 or $3 per exam that we administer. And that's like with 400 or thousands of students, that becomes non-trivial. So we don't want students to take unnecessary exams. It's extra stress for the students too. We want students to engage with space study. We want them to study the same thing multiple times if they need to. And then that's also if we want students to master the material as best as possible by the end of the second chance exam. And we want students to see second chance exams as beneficial rather than burdensome. And this is something which we have seen that depending on the policies, students feel like, oh my gosh, I have to take both the first and the second chance. So now I went from 3 midterms, now I have 6 midterms. And how do we make sure that they don't feel stressed, but see this as beneficial as like, hey, we're trying to help you and we don't want to stress you out. So we've done a series of studies. I'm just going to share about 2 of them that we've done. And so this first one was where we're comparing the effects of second chance testing across multiple courses. And again, so the first question that we asked is like, what effect does this have on students' learning and exam scores? And a consistent finding we had across several different courses is that the distribution of the second chance exam was almost always skewed more to the right. Students performing better on the second chance exams than on the first chance exams, then average effect size was about 0.61. So this is across several different courses doing various different, independent of the policies they used. Students were coming back and learning more on their second chance exams, but you are seeing like lots of students still not performing great on these first chance exams for like this particular course. And so whether this is students being unprepared or like engaging in that instructor sanctioned procrastination that we were talking about, where it's like, oh, I have the second chance, so I don't need to study for my first chance. There is still a surprising number of 0 scores with some of these early studies. So this is a consistent finding across several courses that we had, that students are coming back and performing better. So this is a great question. We don't know if it actually means they're learning more. So that's one of the reasons why this is just one piece of evidence, and we try to do some more studies later, which I'll, yes. So is it that they're just learning how to take the test that we're giving them? That there are some later studies that we try to tease that out a little bit more, and I'll get to that. This is
I have another question. This is Sarah Harris. So is the second chance exam the same types of questions as the first chance exam?
Generally speaking, yeah, because we're using those question generators. I will note that, like in my course, we have this exact same distribution, but I give all my students these question generators before. Like I give them a practice exam that is literally the same as the exam, except it's different variants, and they can create as many of those as they want. And so if they wanted to learn the questions, they already knew it before they took the first chance. And so students are still improving on their second chance after they've taken the first chance, given the question generators in advance. And so, yeah, these are great questions. And so we try to tease it out, and I'll show a different study later where we try to tease it out, because this was across several courses. There's only so much things that we could do in common across all of them. And so then the next question is, does policy matter, and what are some of the hints that we have towards that? And so getting back to like human psychology and motivation and thinking about how that all works is, if the stakes are low enough, you don't actually, you don't put forth the effort you would need to actually really engage the testing effect. If you're just same, like what I was talking about with homework is so low stakes that and the goal is just to get it done, and I have all these extra resources, I might not actually do the homework myself. I'll get it done, but I didn't actually test myself in the homework. And that's one challenge. And then there's all the other issues of like, if the first chance exam is too low stakes, then students just don't take it. They don't even try. Or the other problem that we see is if there's no consequence for taking the second chance exam, students just show up. And then on the other hand, if things are too high stakes, you stress students way out too much. And it also poses other inequity issues of just students who might be less prepared, underprepared, are penalized overly too much for a first chance failure, even if they did eventually learn the material. And so we want to emphasize, we want you to learn we eventually want you to master the material, and that's the goal. And that's one of the advantages of mastery-based learning. But if you don't master the material, that's really what we're concerned about. And so a student who failed the first test and then performs well on the second test, we want to encourage that. Like we want them to come back and study, and how to make that possible. So yeah, and yeah, great comment in the chat. So here are, like, again, this is across different courses. So the instructors chose their own their own policies, and we're going to do some follow-up studies on this later. But this course, this mechanical engineering course, they had a policy of, you can take the first chance, and if you decide to take the second chance, you will not perform worse. Your grade is, you have insurance. No matter what you get on the second chance exam, you at minimum keep the score of your first chance exam, or you can perform better. And so what we see is there's a degree to which some students are still, not doing great on the first chance. There's a number of students who are still performing pretty poorly on the first chance exam, which is unfortunate. But one of the things that we see here is you have so many students, like all of these students with 100% are coming back and taking the second chance exam. Like this defies all expectations. Like this makes no sense. But this is not just a trivial number of students. This is a lot of students who did really well on the first chance and just coming back and not really even trying on the second chance. Why are they doing this? I have no idea. But there's a non-trivial number of students doing this, and and so if the students do better on the second chance, we average their first and second chance exams. There's some formal weighted average, and so this is a really interesting behavior, which in the computer architecture class, like students, we had a policy of we fully replace your first chance exam on the second chance exam score, but we cap it at 90%. And so you can see like no students scored above 90% on the second chance exam. So if you want to get 100%, you have to get on your first try. If you don't, then you don't get to take it. And so, and not surprisingly, students who did okay don't come back and not try. And so we don't have nearly as many frivolous retakes as possible. But if you look at like the surveys of students, this policy stresses students to weigh the crap out. This one, students are pretty chill, and like this is works. And so there's always these trade-offs, but this is part of what we're trying to explore. And again, we investigate this a little bit further in follow-up studies. And does this like, so the other stuff that we wanted to check to see is, does introducing a second chance exam affect students' preparation? And so one of the things that we checked was, okay, we have this online learning system. We're just going to check to see how many submissions students are making before each exam. And because students can self-schedule, the exams can be scheduled over a couple of days. So what you can see here is this is the days that students take their exams. So it's in days 5, 6, and 7 is when students are taking their exams. And not surprisingly, you see students aren't really studying. So we're doing all the homework questions, all the practice exam questions, and there's this massive spike of studying right when students are about to take their exam. So students are waiting, not surprisingly, till the last minute to study. And without the second chance exam, you see no one's taking the second chance exam, and no one's taking an exam here. But when we add a second chance exam, we get a nice little spike of students coming back and studying again for the second chance exam. And so roughly speaking, the average student so not every student needs to take the second chance exam. So once you filter out the students, you filter down to just the students who chose to take the second chance exam. Those students studied 60% more than they on top of, so if they spent, 100 hours, no, they didn't, studying for the first chance exams, then they spent 60 more hours studying for the second chance exam. So students put 60% of the effort towards their second chance exam that they put for their first. And also importantly, there is no statistically significant difference in the amount of studying that students did for their first chance. So we didn't see a decrease in studying for the first chance, and we did see students coming back and restudying, which is exactly the behavior we hope to see on average. So Charlie's question is really interesting. I'd love to talk about that at the end, but this is a great question. Please remind me about it at the end if we have time. So several of your questions that you guys had are really great questions, and these are some of the things we're trying to tease apart. And so we did a slightly more controlled studies, particularly looking at policy and how that affects students' learning. And so we have this old policy that I mentioned earlier, what I call this 90 cap policy, where basically if you take the second chance exam, then your grade is the minimum of 90% or your second chance exam score. So we fully replace it and you get capped at 90%. Otherwise, you keep your exam 1 score. And another policy, which is kind of based on that insurance policy we talked about earlier, but trying to think about how to make sure that students don't come back and take frivolous exams. So we created this 90-10 policy where basically if you take the second chance exam, no matter what, you're taking 90% of your best score and 10% of your worst score. So every exam counts, but there's not a huge penalty. And we chose 90 and 10 just so it matched the 90 cap as close as possible. Otherwise, you keep the exam 1 score. So just what effect does this have on students? And kind of ask the same 3 research questions again. And so just to give you a sense of how this all worked out is we had a mixture of frequent assessments and second chance exams. So we had like seven midterm exams, 1 which didn't have a second chance. And so students got a first chance, second chance on Boolean logic, one on state, on working with the MIPS data path, adding new instructions to the data path, stuff like that, programming, and so on. And for the most part, these students performed about the same. And so we used exam 1 as a baseline measure and said, how do students do on exam 1? Are the populations relatively the same? And statistically significantly not different. So as best as we can tell, their incoming knowledge, the students didn't differ at all. And so does it change who takes the second chance exam? How does this affect student learning within the same course, same content, same exam structure, same everything? And what we found is that, yes, indeed, it does have an impact on which students take second chance exams. And particularly, if we broke this down further, basically what you find is students who got a high C to a low A, because that 75 to 95% range, are the students this really particularly affected. That these students with, kind of going back to what we talked about earlier at the talk, this borderline mastery, they know some of the content, but they haven't nailed it yet, are coming back and taking second chance exams and are more likely to take it. And this is particularly who it's affecting. And so students who got D's and F's, they're going to take the second chance no matter what, because they failed that exam pretty badly. But these students with borderline mastery are more likely to come back with this new 90-10 policy, which is what we're hoping to make happen. So the second question, and so does this affect how students study? And so just like before, we have this window of when the exam is happening, and here it had zero effect. The study habits of students across the two policies were basically identically the same, no effect on study behavior. But does it affect student learning is particularly the interesting part here. And we were expecting a null result. And so we're still wondering exactly what happened here, but this is really exciting to me. So we had the 90 cap policy in 90-10. And as you mentioned earlier, there was no statistically significant difference in the students' preparation or incoming base knowledge. And so no statistically significant difference. And this was held true for the first several exams. But once we got to exams 4, 5, and 7, and we tried this as many different ways as we could. We tried it with what was students' performance on their first chance exam only. So there was no possibility, we minimized the possibility that students just took the exam, memorized the questions, and came back and tried it better on the second chance exam. We tried it that way. We tried it with their aggregate scores. We tried it with and the result kept coming back exactly the same, regardless of how we measured student performance on these exams. And I'll note that I had been giving these same exams for 3 semesters prior to the study, and the exam averages had stayed consistent. There's no statistically significant difference historically between semesters. So something changed this semester. We were switched to the 90-10, and that is unique across 4 years of the course, basically. So I'll talk about exam 6. I excluded that in a second. So because we changed the structure of exam 6 pretty dramatically. But for exams 4, 5, 6, and 7, we are seeing statistically significant differences in students' performance with moderately large effect sizes. And again, we did nothing other than change the course policy. And again, also students performed better on the final exam. So we got rid of exam 6 from this data. We did this before we even ran the tests because we moved that from a paper-based exam to a computer-based exam, and we changed the structure and nature of the questions. So the exam 6 was not the same exam 6 across the 2 semesters. And so that was why we excluded that one intentionally, because the grading was dramatically different. And so it just wasn't comparable to that. Yes, students definitely talk. This is part of the surveys, and just anecdotally, when we talk with students about this, they absolutely talk about strategies. How do we approach this exam? How do we and yeah, that's there's definitely an attempt to figure out how do we best game the system to maximize our points. And so there is a bit of gamesmanship there. And so yeah. Sorry. I didn't tell students how to take. I don't even tell them I didn't even tell them that we changed the policy. I just said, here's the policy this semester. And so I didn't try to change how they're thinking about it. So yeah. And the only thing I really try to drive my students thinking is, I want you to attend class. I think my class is valuable. I have distributions that show me like students who attend class do better. So that's pretty much where I spend most of my time. Like, please just come to class. That's about the most where I change that, do that with my students, of like, I would try to verbally change their behaviors. And so this was a bit of a surprise. We were expecting that this wouldn't have an effect, but it did. And we were pretty excited about this, and COVID-19 happened and we can't replicate this yet, but we're going to try this in some other classes and see if we can do this when we have a more controlled environment to try these studies out and see if it has an effect in other courses. And just kind of last thing is, does this affect students' student experience? And so students generally felt like, yes, this is a more fair policy. It was less stressful. And that's also encouraging that, like, I think hopefully we're finding the spot where we're maximizing students' engagement and learning while also not making it too stressful for students. And so hopefully that's kind of the goal that we're aiming for, is using assessment in a way that really is high stakes enough that students engage meaningfully, but low stakes enough that they don't get stressed out. And that's what I think is really exciting and encouraging about this as we look at student behavior and student learning. So what does this mean, or how do I interpret kind of all of this finding, is that I think what the 90-10 policy is, it incentivizes these students with borderline mastery to come back and try more. And why do I think there's a difference in learning is kind of this model here. What I hope is happening is that these students who didn't quite get some of that early content got it, and they're better prepared to take on later exams, later content, and could demonstrate borderline mastery or full mastery of material that they didn't learn earlier, and that they're better prepared for that learning. And that's what I hope, and I think this is going on. We have to do some more applications, some more deep control, better design studies to really tease apart that particular question and to see, is that a robust finding or not? But I think, again, looking at the cognitive science and kind of what we know about the way that this stuff works in other contexts, I think that's a reasonable interpretation. That if we can get students coming back and relearning stuff, that is going to actually help students learn more in the long run. And so what I hope, and this is the biggest or most exciting takeaway for me, is that, like, this is almost no work for me as the instructor. I didn't have to change what I was doing in the classroom. All I had to do was change my schedule and change how I chopped up my exams. I didn't make more questions. I just changed when I scheduled them. And that there's like pretty consistent findings across several courses that this does seem to be improving students' performance on cumulative final exams. And that is, I think, a goal. Is it the entire goal of learning? No. Are there other things that we need to be doing to address things like conceptual learning or more? Yes. I don't think this is the end all be all, but it is a tool that I don't think we are talking about enough. And I think it's a low cost tool that we can deploy in our arsenals to provide benefit to our students. And that's kind of the end point of where I want to stop. So happy to take more questions. Happy to dialogue on any other issues that you have.
Hey, Geoff. Thanks a lot for your talk. It was very interesting. So a couple of questions. One is, you've said multiple times it's very low cost, and I can appreciate that it's low cost, low maybe maintenance cost. But it seems like, you thanked 20 people or something, and it seems like it's a huge upfront investment to get it in place. Can you speak to that at all?
Yeah. So this is, I cut a figure that I often have in this, is like the way I would describe my prior teaching was that, like, if this is like the amount of effort that I put for, like, if this is effort and this is like over time, when I'm writing and don't have all of these stuff in terms of like question generators, my level of effort for every exam was somewhere up here. And so now, like, what I've based, like, so yes, with with all those question generators, my effort had to spike at some point, but now my effort to like do all this testing is much lower, certainly less. So that is, there was a huge upfront cost, but I'd rather pay that huge upfront cost once. And so like, yeah, then every semester I get to just focus on actually engaging with students, helping I get to do, I use the technology to do what technology does really well, which is, just feeding my students practice questions. And then I get to do what I get to do well, which is the high touch part. I don't spend my time writing test questions. I don't spend my time grading test questions. I spend my time engaging with students. So that's kind of the main goal of that. So yes, there is a huge upfront cost, and but I'm happy to share what I have with that. So so great. So follow up on Charlie's question and all of this about the question generators. So there is so we do have some. I think some conceptual questions you can always like. There are some degrees of conceptual questions which have forms. Like, so if I'm going to do this with the force constant inventory because it's easier. So it's like, for me, it's like they'll have like, oh, what's the trajectory of a ball? And so they'll have like, there's the actual answer, which is, parabola. There's the ball goes out, and then it's Wile E. Coyotes realizes it was over the cliff and then falls straight down. Or it's, it's a linear path or whatever. And so I can program a conceptual question that, draws different variants of this with, different starting velocities, different whatevers. And so it's still a conceptual question then get at that. So that's one way to address that. So I don't have to have the same slopes. I don't have to have the same intercepts and whatnot, and we can engage students in that way. I also occasionally will just write several variants of a question. And so I do this with caches in particular. Like, I want to know, can my students reason about how a piece of code works with a cache? I can't quite at least I don't have the coding skills to create code, any arbitrary piece of code automatically. Like, I just can't do that. And so like I spent, like a couple summers just writing, 20, 30 variants of this so that I have a huge pool of questions to pull from that engage students in interesting cache analysis questions. And so there are some things which I can't fully auto-generate, but then what I do is generate a pool of questions that I can then engage those students with. Yeah.
So I have a, oh, I'm sorry, go ahead and answer the question in the chat and then I'll ask one, okay?
Okay, so that's just Jared's question of like, is this stuff available for adoption? Yes. PrairieLearn is an open source system, so you can either like host it yourself, or we're working on trying to provide more support for other institutions. And this is stuff like everything is written. I'm trying to get everything in just Python, and so it's all the scripts are easily portable and runnable anywhere. Some of it's still in JavaScript, which is not great. Very bad JavaScript. So trying to switch it over to Python. Yes. So Ed, sorry.
Okay, yeah. So I was wondering if during the pandemic you had a concern about cheating. For me, when I do exams, I want everybody to take them at the same time, and then that kind of means that you can't do self-scheduled second chance exams.
Sorry, could you?
Okay, so you want me to rephrase it?
Yeah, I'm not certain I followed the question. I felt like more like a statement than a question, so I missed.
Okay, well, did you have a problem with cheating if the students are able to self-schedule exams and take them more than once? Or actually, if they're allowed to self-schedule exams, even if they don't take them more than once?
Okay, yes. So with the CBTF, there's definitely less sharing or cheating. I can say that pretty confidently because with the online proctoring, my exam scores jumped about 50% higher like than they normally are. Like the number of students who are getting A's jumped by 50% on each quiz, which was like, something changed, right? And it's the amount of proctoring. And so Craig Zillis, my collaborator, has been studying the cheating aspect a lot more. And so basically what they found is if you have at least 4 variants of questions in a pool, students aren't able to effectively cheat. So, because I guess think about it from this perspective of if a student is struggling enough that they feel the desire or need to cheat, they probably don't have the expertise and ability to learn and memorize solutions to more than 4 questions, right?
Yeah. Mm-hmm.
And so if you have like, so even if a student knows like, oh, there's like these 4 programming prompts on the quiz, they don't have the capacity to cheat effectively if that's the case. And so like, so the studies, some of the studies is like, how does the size of the question pool affect student performance? And do we see evidence of cheating? Because there is a window we can kind of track to see student performance on questions as it goes on, time goes on. So some of the things that we do see, generally speaking, as student performance go, like I can show you any, I could pull up a random quiz from my class and show you that the average score on the quiz goes down as time goes on. It's a pretty straight linear relationship. It's like this, and a pretty steep slope, basically an average of an A on day 1 to an average of C or D on day 3. That, and
See,
I don't think that's, yeah.
I'm thinking that the biggest barrier to other institutions adopting this is the need for the CBTF. But if you could do online proctoring or something, I'm not sure I like online proctoring either, then more places could adopt this and the technology could be more widely used and benefit more students.
Yeah, and I think COVID has shined a light on that issue of how do we proctor effectively online, and that's a great question which you don't have an answer to. So I will say, so frequent testing isn't something you need the CBTF for. Second chance testing, you don't need that either. Like we were, like several of the instructors who've been participating in this, we're doing second chance testing with paper-based. I just think the ongoing cost of doing it is a lot cheaper once you can have some form of creatable exam. And so, for example, like the mechanics course that I was mentioning, they basically used their question generators to print paper-based exams. And so they just ran, like they basically just had a Python script that used all these question generators, generated a random exam, and then gave that to the students. And so, and they actually, I think they got to the point where their script was sophisticated enough that every student got, slightly different numbers. So one student got a 25-degree angle, some different student got a 20-degree angle, so another student got a 30-degree angle. Yeah, so there are ways to do this, and like we can also share some of those tools. And so for doing this with paper-based exams as well. And with the frequent testing, like all you're doing is just taking your existing exam question pools that you author your exams and just offer them at smaller increments of time. And so maybe you don't have to have evening exams. You can just do 30-minute in-class exams. And so you can just, there are other things that you can do to change this. I think it's 9 o'clock, so I probably should wrap this up. And there are, so we do have an API. Someone asked about Canvas. We are working on an API. There is some API support for working with learning management software. I know we are particularly working on trying to get Canvas better integrated. And I know it's working well enough with things like Coursera at this point. So I know we have several MOOCs with Coursera that are doing are working with Prairie Learn to serve questions to students. But that part I've not used because I've not had to yet. So I can't speak too much about what that experience is like, but it does exist. Yeah.
Great. Okay, well, thank you, Geoff. That was a great talk, and a few people have said so in the chat, and I'm sure everybody appreciated it. We'll now have a break, and I think let's have 8 or 9 minute break. We'll come back a few minutes after 10 after the hour. So about 12 after the hour, we'll be back, and then we'll start the next session, which is mostly pedagogy, but a little bit on adapting a course for online delivery. So thanks everybody, and we'll see you in a few minutes.
Thanks.